Hey guys, all right, so this is example 3 for 4.1. Use analytic methods to find the extreme values of the function on the interval and where they occurred. Example A says g of x equals e to the x, and the interval is a closed interval between -1 and 1. First, what you want to do is, it says here, use analytic methods to find extreme values. So first, you want to find the critical points. So find the critical points. The critical points from the definition earlier is when the derivative is 0 or when the derivative does not exist. So first, we have to take the derivative. The derivative of e to the x is e to the x. Okay, you want to solve for x. Solve for x because the critical point again is where it equals to 0 or where it doesn't exist. So when the critical point equals to 0, we want to solve for x. Well, obviously it's an exponential function, and in exponential function, it's never going to be 0. So this is not possible. Okay. Next step, step number 2, we want to remember the extreme values is we're looking for minimum or maximum. Okay, so and based on the definition, it's when the derivative is equal to 0, or as you can see, by definition, the critical point when the derivative doesn't exist, and also the endpoints, right? If it's continuous, the endpoint could also be the min or max. So second, we want to use endpoints and plug into your function f or g or h, whatever it is. Okay, this is to referring back to the extreme value theorem. Well, you have an endpoint of a -1 and a +1, so we'll plug that into your regular function g of x. So g of a -1 and g of a +1. That's e to the -1, which is 1 over e, and this is e to the 1, which is e, which is about 2.718. So if you think of this, okay, your derivative was not defined, okay, then your endpoint, one of it is 1 over e, which is 1 over 2.718, which is about a third, and then this is about 2.718. So you only have 2 locations, and as you know, e to the x is continuous, so this is a continuous closed interval, and based on your extreme value theorem, we know there has to be a max and a min. I'm using the word max instead of an absolute max, and that's stated before in the definition. Max is e, which is the higher of the 2, at x equals to 1, and your minimum value is 1 over e, is what I meant to write, at x equals to -1. So when it says use analytic methods, it's asking for you guys to write it all out. And we're going to try the same thing for example 3b. Example 3b gave you k of x equals e again to the -x squared. And this case is talking about the domain of all real numbers. And similarly, we're going to start with use your critical. Find the critical points if there's any. First, find critical points. Okay, so critical point is talking about the derivative, so I'm going to use u substitution. So u equals -x squared. U prime will give me -2x. I'm pinching in a little bit because it tends to freeze on me when I'm is if it's too stretched out. Then that means my k of x equals e to the u. The derivative, which is k prime of x, equals e to the u times u prime. Okay, so let me pinch it in one more time to see if it stopped freezing on me. Okay, so with this said, I now have to plug u back in and u prime back in. So k prime of x equals e to the negative 2x squared times u prime was negative 2x. And I'm just going to move the negative 2x in the front just because I want it to look pretty. Nothing wrong with putting it back. Okay. Oh, my bad. U is just a negative x squared. So let me erase my negative 2. Negative x squared. Erase that. Okay, and then erase this. Let me fix my x again. Okay, so currently we have the derivative, which is times e to the negative x squared. And now, remember, we have to solve for x. So let's solve for x. So set it equals to 0. Or you know what, let me spell that out for you. Solve for x. That means we're going to take k prime of x, make it 0, equals negative 2x e to the negative x squared. This is a factor. So you can take each factor and set it equals to 0. Well, this one, x is straight up equals to 0. Well, as we know already from prior example, that if it's an exponential, y can't be 0 or negative. So this is not possible on this side, okay? So currently, we have x equals to 0. That's one location. So let's move down here. Since there are no endpoints, and we have one critical point, that's what we are going to use. Now, if you have critical points and endpoints, you plug them all in back into your original equation. So second step, plug critical points and endpoints back into F. Okay. In this case, we're using K. So again, if you have endpoint, you will have to do all of them. Since we only have one, your critical point was x equals to 0, so we plug in 0 for our original, which is e to the negative 0 square, which is e to the 0, which is going to be 1. Since there's no endpoint and we are unsure what k of 0 equals 1 is, right? We're not sure. Is it a min? Is it a max? I'm going to use a number line. Use a number line to see if k equals to 0 or at x equals to 0, it's the highest of the highest or the lowest of the lowest. So here's x. X was at 0. And we know k was 1, so the y value was 1. What we want to do is we want to pick some extreme value, such as k is negative 100, which is the left side of 0. K equals positive 100. You can pick negative 1, you can pick positive 1, you can pick anything to the right or left of 0. It doesn't really matter. You're just trying to see, hey, is it higher than 1 or is it lower than 1? So when k is negative 100, when x is negative 100, your original equation was e to the negative inside, it doesn't look like a negative inside, here we go, negative inside 100, and then we're squaring it, so that's going to be a e to the negative. Would you agree that whatever that number is, it's a negative number? If it's a negative number, and technically you can pick 1,000, right? It doesn't really matter what number you pick on the right or left. You can pick 1,000. So it doesn't really matter. So pick one on the right and pick one on the left. So each is some negative number. Again, I said it doesn't really matter. Then what you want to do is, okay, well, what happens? You want to do 1 over e to the positive something really, really big. That means this is getting very, very close to 0. Okay. Then we're going to do the same thing to this side. And again, I've chosen 100. It doesn't really matter. E to the negative, similarly, we're going to pick 100 and we square that. And it's still going to turn out to be e to some ginormous number here, 100,000. Well, 1 over e to a positive big number, again, similarly, it's going to give us a number close to 0. Well, both right side, both left side of that location, 0, 1, is very close to 0. That tells me that this is the highest point. So what this is going to look like this, right? Something like that. So this is going to be the max. So that's what our answer is going to be. Max is 1 at x equals to 0.